The second part of the video. Freechains is a topic-based publish-subscribe system with data persistence. In other words, we have topics or groups represented here by the planes. We call them as chains. And when a participant posts a content to a chain, all other participants subscribed to that chain will receive the post. We consider the chains to be persistent because from a given post, it is possible to reach all other posts from the past. The dissemination follows a gossip model in which the peers in the network, each one represented here as a rectangle, communicate peer by peer. As we already discussed, Freechains order the author's posts with a happened before relation with best effort. Events that have a cause and effect, for example, a question followed by its answer, will always have the order preserved. But independent events, for example, two answers for the same question, might be delivered in different orders by the peers in the network. Our main contribution with Freechains is a decentralized reputation system to be presented. Each chain has its own independent system to keep the quality of posts and authors. In practice, Freechains is an open source software that can be downloaded and installed on a computer or mobile phone. Freechains execute in the background as a server or daemon that listens to local user requests and communicate with other peers in the network. The daemon can be accessed in three equivalent ways: from the command line, which we will use in the rest of the presentation, from an API in Kotlin, which can be used to create applications on top of Freechains, or yet directly from a textual protocol that permits to use other languages via sockets. Let's now use Freechains from the command line in Linux. The command host create initializes a local file structure of a host in the given directory. This command only needs to be executed once. Then we start the daemon in the background with the command host start, passing the directory of creation. Now users can connect and issue commands to Freechains. The same commands can be executed in other machines locally to prepare the network, but there is still no communication among them. Let's give an example of communicating using a public identity. That is, an author, for example, a news site, wants to broadcast its content for a target public, which can provide some feedback. We need to create a pair of keys for the author. The command crypto create derives a public and private key from the given passphrase. The answer is a pair of keys, a public shorter and a private longer, which should be kept safe in secret. The public key is the identity of this author and should be shared with its target audience. Whenever a post has this public signature, it means that it was posted by the user holding the private key. Now we use the command chain join to create a chain locally. Here the command receives two arguments that are almost the same. The first is the name of the chain that always starts with a slash. The second argument is the public key associated with this chain. This chain was created so that this user can disseminate its content for other participants. We use the key in the name of the chain as a convenience, since the other users already need to know the public key. Chains for public identities are not the only kind of chains. The next command creates the chain /chat without any associated public key. This kind of chain will be used in end-to-end communication that we'll discuss in the future. Going back to the public identity chain, we call its owner, who controls the private key. The owner has infinite reputation and can moderate the contents of the chain. Now let's consider another user that uses the same command to join the chain in another host. Create the same chain locally. This user doesn't have the private key, so he's a consumer in the one-to-one communication pattern. Even if the chains were created in different hosts independently, the chains are the same because they were created with the same arguments. We can verify that with the command chain genesis, which reads the first post that exists in the chain implicitly. We call this post as the genesis block and obtain as an answer its hash code. We can verify that this hash code will be the same in any host for a given chain. Here we have a diagram of the chain with the genesis block. Finally, we post a new content using the private key. The command chain post creates a new post locally and points to the set of existing blocks in the chain to comply with the best effort strategy. The prefixes 0 and 1 in the blocks indicate their heights in the chain. In the command, the contents are passed inline as hello world. It's also possible to give a file name here. The post is signed with the given private key. The state of the chain is local, and the contents were not disseminated yet. Let's recreate the steps of the previous slide with some more context. Our author, Mary, is connected to a computer with Freechains. First, she creates an identity with the command crypto create. Then she discloses her public key and hides her private key. She then uses the command chain join to subscribe her chain in the host, read with the genesis block. Then Mary posts a new message on the chain with the command chain post and uses her private key to sign it. By other means, Mary reveals only her public key to John, which is connected in another machine to Freechains. As the identity of Mary is public, John can forward it to his friends that might be interested in content of Mary, even without knowing her. These other users can now use the command join to also subscribe to Mary's chain. Mary can also have another computer at work or her own phone, which can be used alternatively, even as a backup of her chain. Finally, to disseminate the chain content, Mary uses the command chain send, which will send all blocks that the destiny still doesn't have. John must also forward the content, since Mary is not in touch with all of her followers. This is exactly the process of gossip among the peers in the network. As a last observation, the machine that Mary used to post the message doesn't have any kind of privilege. The only authority here is her private key. She could use it in another machine in the same way. Now let's exemplify communication in public forums. That is, authors do not know each other, there is no supreme authority over the chain, and it's possible that there are malicious users. A public chain is moderated by its autonomous reputation system with input of its users. John likes to cook and had the idea to create a chain in Freechains to share recipes. He immediately posts a description for the group with his signature and invites other friends to participate. Since he signed the first block, the reputation system awards John with plus 30 reps, which is the unit of reputation. A question that can be raised soon is that another user anywhere in the world could have the same idea and also wants the plus 30 reps. In fact, names are free since there is no centralized registry. For free chains, these chains could coexist unless they need to synchronize at any point. That is, if Alan tries to synchronize with John, the operation will fail. Chains with different first blocks never synchronize. Going back to John's chain, Mary tries to post a new recipe which enters at the head of the chain. But since Mary has no reputation, the block is initially blocked and awaits for a like to be accepted. For now, only John can approve new blocks. He approves the content and gives a like in Mary's post, which is now accepted in the chain. This reputation is transferred between the two authors. John receives a -1 rep and Mary receives a +1 rep. However, new posts count negatively for each author for 24 hours. So Mary is still penalized with -1 rep, what prevents her to post again. After 24 hours, the post becomes positive, and Mary now has +2 reps which she can use to post or moderate other posts. Considerations about the reputation system of Freechains. The first author is 30 days ahead and shapes the initial chain culture. Also, it's only possible to have one first author per chain. Hosts that disagree can never synchronize that chain. New authors need initial approval in the community and grow their reputation slowly. New posts are initially penalized. This means that authors must behave because volume is not awarded, only quality. Consolidated posts form the community economy, since they are the only form of production, but they are still subject to further moderation. In the next video, we will give more details about the reputation system.